Hello everyone, and welcome back to Flying Through the Gyroplane Flying Handbook. This video will be on Chapter 3, which is probably one of the shortest chapters. It's only 2 pages long, and it's all about flight controls. So let's get into it. Every gyroplane has a cyclic control. So what does the cyclic control do? It pivots the disc. It tilts the disc, and that's pretty much it. Now, if you look at this picture here, this is a direct overhead stick, and this is something you might actually find in some of the old Bensons, some of the things from that era. I actually saw a gyroplane recently that had both the overhead controls and a traditional cyclic stick. Now, what's wrong with the overhead controls? The biggest issue I would say with the overhead controls, it's like flying a weight shift ultralight in that everything is reversed. So if I want to go up, I push forward, which will tilt the rotor upward. And if I want to go down, I actually pull back, which is 100% opposite to what you would normally expect if you've ever flown a helicopter or an airplane. Similarly, if you want to turn, you have to tilt the wrong direction. We also have our throttle control. Now, the throttle control is going to be different with different gyros. Many gyros will have a throttle that looks like this, where you have a lever that you push forward. Occasionally, you might find a gyro that has a twist throttle, similar to a helicopter, and a lever that looks like a collective lever from a helicopter, but may or may not be a collective lever. I've actually seen things like a twist throttle with a lever that was used for pre-rotation. So here we have traditional cyclic and a throttle as well. And you can see the push-pull tubes. I'll show you in a little bit what this looks like in the Gyro Technic Gizmo, the little model gyroplane. And then we have our rudder pedals. And they work pretty much like they do in an airplane. If I step on the right pedal, it will deflect the rudder to the right, which will cause the nose to go to the right. And the last control that they mention is a collective control. Remember that we said most gyroplanes do not have a collective control. They're just a fixed pitch. They're much simpler than a helicopter in many regards, and that's one of them. You can have gyroplanes that will have a collective control in order to do things like a jump takeoff. However, if you have a gyroplane that changes its pitch, in the United States at least, it cannot be considered a light sport gyroplane, which means you would need at least a private pilot license in order to fly such a thing. So that's one of the issues that you need to consider if you think, hey, I want to buy one of those really cool jump takeoff gyroplanes. Okay, so let's have a look at our gizmo. So if we look at the flight controls, the most prominent, of course, would be the cyclic, or the stick that you hold normally in your right hand. And that stick is right here. So you'll notice as I push forward, my disc, my rotor, tilts forward as well. Now, one of the things that's definitely to be noted with a gyro is that as I push forward, my rotor only goes to level. It doesn't go to being actually forward tilting. And remember that the reason for that is very simple. We need our air to be going up through the rotor, never down through the rotor instead. Now, if I look at what's happening mechanically, you can see the attachment at the top of the rotor head. And as I move the cyclic left and right, it's going to tilt the rotor head. And as I push it forward, it will tilt it this way. So you might say, well, how does all that happen? It's actually very simple mechanically. So here is the bottom of those tubes that are connected to the rotor head. And from here, if you watch when I go left and right with my cyclic stick, it's tilting this little Y. And when I push forward, it's tilting it up. So it's a pretty simple system that we have for the cycle. What are some other simple flight controls that we're normally going to find? Well, that would be rudders that control our yaw. We talked a little bit, we talked about aerodynamics, why this is important in order to keep the aircraft in trim. So it's always hitting the air dead on. Of course, we also need rudders in order to do things like steer on the ground often. And in addition, we need it to keep the aircraft straight when we're landing in a crosswind. And how do those work? Pretty simply, if you'll notice when I push on my right rudder pedal here, there's some cables that cause deflection in my rudder in the back. Similarly, if I push on the left cable, you will see deflection the other way. If I zoom in here onto the rudder, see a little better. Here's pushing right rudder, and here's pushing left rudder. Something else of note, you'll notice that the rotor head has a pre-coning angle built into it. So if I look at my bar here, my bar is not completely flat. It's actually bent a little bit. And that's pretty standard. Of course, my rotor head also has the ability to flap or teeter. And we talked about that in our aerodynamics section as well, about the need to fix the dissymmetry of lift that we have in any rotorcraft. So again, you can see the mechanism for the pitch. There's a spring on this guy that will pull the rotor system down in the back. So it will give it a upward pitch by default. And again, if I push to the sides, you can see how it's going to tilt that direction. And that's all for this video. We'll see you in the next one.